We are being asked to find the distance between 2 points, and I'm going to show you a couple different ways to do that. The way that you may be most familiar with is by using the distance formula. Now, the distance formula is something that you have to memorize, which is crummy because memorizing things is hard. But the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then you take the square root of that whole thing. All right, so to use the distance formula, you just plug these points in for the x2s and y2s and x1s and y1s. And so I always find it best to label my points so that I don't get confused. So if this is going to be point 1, that makes this part x1 and this part y1. And if this is going to be point 2 rather, this is x2 and y2. And now I can just start plugging stuff into the distance formula. So I bring down my big square root. All right, x2 is 3 and x1 is negative 2. So I'm going to have 3 minus a negative 2 quantity squared plus. All right, and then y2 is 5 and y1 is negative 1. So I'm going to have 5 minus a negative 1 quantity squared, all underneath that square root symbol. Oh, I need to double close those parentheses. Need to double close those parentheses too. Okay, so now I keep working on the math. 3 minus a negative 2. That's the same thing as 3 plus 2. So right there I get a 5. I still have my square root symbol all the way across. And don't forget to bring down that squared that was right up here. All right, plus, and then in here, 5 minus a negative 1. Minus a negative is the same as plus. So 5 plus 1 is 6. Don't forget to bring down your squared. All right, and then you can do this in your calculator all at once. 5 squared plus 6 squared, that's 25, plus 36, so that should be 61. So you've got the square root of 61, and then you can simplify that. You can simplify it by typing it right into your calculator, and the square root of 61 is about 7.8. So if I were to measure that segment between negative 2, negative 1, and 3, 5, I would find that it's about 7.8. I'm going to show you one other way that you could have done this problem, and in order to do it, you would need to graph these points. So the point negative 2, negative 1 is right here. And the point 3, 5, 1, 2, 3, 4, 5 is right here. All right, I want to know the distance between these 2 points, or how long this segment is. Well, if you have the distance formula memorized, you can use this. But if you do not have the distance formula memorized, you can always turn this line segment into a right triangle, and then you can use Pythagorean theorem. So let me get a different color here, even different than that. Here we go. All right, so if I go straight up and straight across, now all of a sudden I have a right triangle. All right, this side of my right triangle is 1, 2, 3, 4, 5 units long, so I'm going to put a 5 there. And this side of my right triangle is 1, 2, 3, 4, 5, 6 units long. And then if you remember back to pre-algebra for sure, and maybe even before then, you learned how to do Pythagorean theorem with this. The Pythagorean theorem is a squared plus b squared equals c squared, and this is actually on your geometry formula sheet. All right, so you can put these numbers in, 6 and 5, in for a and b, and solve this equation. So you'd have 6 squared plus 5 squared is equal to c squared, and c is going to be this piece right here that you're solving for. 6 squared plus 5 squared is 61. And then the opposite of squaring something is square rooting it. So then you take the square root of 61. And we found over here that the square root of 61 is 7.8. So you are free to do these distance problems either way, either using the distance formula if you memorize it, because this is not on the formula sheet, or using Pythagorean theorem if you want to graph the points.